Ladies and gentlemen, I would like to welcome you to this last session for today. And I would kindly ask you to take your seats. We have three distinguished guests here this late afternoon with us to tackle a very important topic. As I think I said, I announced in my opening short talk yesterday, we have introduced this new session in RTR, in the RTR conference, with the ambitious title you can see projected on the screen here. So we are going to talk about the shareholders' experience on successful integration of research and innovation projects. As you know, I'm sure you all know because you are very experienced, impact of the European research is highly evaluated and requested in the EU projects. As a matter of fact, it is one of the most important parts of the proposal and equally very important in the overall evaluation of the final evaluation of the project. So this session is really about impact. However, we do know, all of us I think, that the impact we see and discuss in the RTR here, pretty much coming from the individual projects, it is limited and incremental. It is limited because it is based on the limited duration of the projects, 3-4 years, and incremental because it can only provide a delta. It doesn't provide the overall view. And this delta is typically calculated between the initial requirements of the project and of the call and at the end of the project. Hence, we thought that with this session, we will try to close this very important gap. Therefore, we try to take a distance from in time and to try to see a big picture, the big picture actually, over a longer period of developments. And it was clear, we think, that the best way to do this would be to ask specific companies, specific institutions about their own experiences over a longer period and over a larger number of framework programs. In this discussion, we will seek to find the patience and, more importantly, I would say, the persistence of the researchers towards innovative products, services, tools, and processes. We want also to listen to possible interactions between EU, national, and equally important international activities on research and innovation, but also to discuss possible failures, which are definitely part of the game and may be required for a successful pathway. So with this very short introductory words, I would like to turn to short presentations of our colleagues, and then we will continue with a discussion. So I would like to, first of all, to invite Horst from AVL to give your view and your company's view.
Thank you very much, Zissis, for this kind introduction, also for the invitation to speak here in front of this audience, actually, which is really very deep in these topics and has a lot of contribution to this topic. So I was also very surprised, let's say impressed is the better word, of the different presentations that we had so far from the project. So I think this shows that these projects are really very good for us and that we make their big progress. So I would like to show that from AVL's perspective. And yes, let's start off. For those of who do not know AVL so good, in very simple words, we have 3 pillars. The first pillar is the engineering pillar, where we started off. So we do the whole design and construction of a vehicle, specifically the powertrain, with all its aspects, and battery electric vehicle, hybrid electric vehicle, and fuel cell electric vehicle. The second pillar for us is also very important. We also produce our own tools and our test beds. This is good, so that we have that together, because we know what we need for the development, therefore develop these tools and these test beds. And the third pillar is also very important. We see this very often in the project, the simulation technology, so the virtual simulation, which save a lot of time if we can do that. And we have that also in-house. So I think this is something very good, what we have here in hand, and this is AVL. What we are doing in terms of content has changed over the time. We were coming from the pure, let's say, powertrain, actually. In the meantime, it's much broader. Our main pillars are here. The electrification is more or less in the center of our developments that we are doing. The other big pillar is the ADAS and autonomous driving pillar, which is growing very fast. There is another pillar that is still there. This is the zero impact emission, which is related to the last developments, also looking, for instance, at other emission like the brake wear or the tire wear, which is introduced also in the new legislation. Vehicle engineering as a whole, which is important for AVL, and data intelligence. I think everybody needs to take care about that, and this is an overarching topic that is very important for all of us. I only want to talk about 2 pillars, the electrification and the ADAS autonomous driving. In the electrification, what I show here is a picture of projects over time in the past years, starting here, for instance, from 2011, with project names that might some of you know. Every project that is marked here with this blue star is actually coordinated by AVL. There are many others where AVL has also participated, but there was not enough place on this slide, actually. And I also show projects where we have not participated, or maybe were in another scheme, so not a green vehicle as it was named in the past, or 2.0 now, but also Excel or KDT, because they fit very well together. So if we look at such, for us it's a research program, yeah? Electrification, electric vehicle batteries. For us it's a big program. It's not just one project. Yeah? That means we have to think about how does this fit all together, and there's a kind of strategy, of course, behind that, how we can bring that together. And out of that project, there are specific results. I can also show you just a few examples, because we see this in all the projects. But what for AVL is coming out is there at the bottom, actually. There are very important outputs that we are using within our portfolio, actually. And I do not go in details here. I show you on another slide. Before that, I just show project here, put this together. So for instance, Obelix, there were specific objectives. So to reduce the development efforts, improve the efficiency of the drivetrain, and to increase the safety all at once. The targets that we have set out ourselves, also by the Commission, actually, we have judged them during the project. We have reached a certain type, a certain percentage here, sometimes even higher, sometimes slightly below. And we had a big project here, partners from 20 different companies, from OEMs, with their use cases, CRF, Ford, Renault, Volvo actually, and also tier ones and a lot of academics also in different areas. And what is also, we see that very often, so the animation is not perfect here. What we see in the evaluation, what is the impact? In nearly every project we see this now, we have the use cases. So the use cases are there to judge actually the technology development and to look whether we have really reached our targets. You do not have to read that actually, it is just to show you there is always a lot of work to make this assignment between what you have in the use cases and that what you really can reach. You need that proof actually, and this is why we came up actually with the numbers, with the improvement. And we touch, for instance, here 17 use cases in the electric vehicle development. So this is one example. There's another one, I go through that very quickly. This was Vision XEV with very similar targets, but more on the system, on the simulation, parameter identification, co-simulation, with a little bit lower budget, therefore not so many partners, and the targets has also been reached here. This was actually done with 4 use cases in this case, which were battery pack design, vehicle design, optimization, simulation. I don't want to go into further details here actually, that's not the point. The important point is, what do we make out of that? And what I show you here is actually that we have the results, and you see here 2 pillars now for the electrification. So one is the simulation tools, which enable higher development speed and higher accuracy in the upfront when you look at the design of the components and you build them up for different electric components. So there are actually tools behind that that we are improving during the project, and this the results are going in there. We need many projects in order to get the whole product, but this is actually it on this side. On the right side, there is also this interaction of the simulation with the engineering process. So for instance, then in different environments like the hill environment, model in the loop environment, and also the connectivity with hardware. So the Model Connect gives us the possibility to do that together with the hardware. There's also other results. We had very much improvements, for instance, here for battery development. So we have a battery design. Actually, we have also a battery innovation center that partly was involved in different projects, but also the results were taken out of these projects to improve that. We have drivetrain development, electric drivetrain. On the right-hand side, you see this was also part of this project. So the wide bandgap development, this was started actually 2011 in this Asterix project, first time. And this has been, at a certain point, put into the battery tester, which is on the bottom on the right, but has also been used then within the car, for instance, for this e-axle improvement. So there's a lot of synergies between different projects and between the results. I think I have to look at the time, how far I have 5 minutes. Okay, good. Then I think I'm in time. So this was electrification. I just wanted to give here certain impressions and an overview about that. I take a second example, ADAS and autonomous driving, because we have 2.0 and CCAM here, the communities and others, of course. The automated driving, this is also very closely related to this cybersecurity. Not only cybersecurity is also in the other part. We heard that before. For instance, no, I don't go into that detail. I stay here. It is automated driving. There are many different aspects actually so projects that we have done here, which have to do with verification of ADAS functions, of verification of the perception system, of sensors, for instance, the methods. There are also German projects here, Pegasus and V&V methods, V&V Methoden, V&V, verification and validation Methoden. These are German projects. But there are always very close relationships, and we try to put that all together in order to find results in certain projects, put them into other projects, impose directions, and also to create the synergies thereof. The results that we got here, you see it on the bottom, but I have another slide to that. And just there, we had the same procedure here. For us, it's always very important what is the impact again. So did we reach this test execution effort? Could we reduce that? The test environment for the verification validation, or also the probability of malfunction. I think you do not have to read that. I think we will distribute also the slides. If you're interested, you can always come back to us. These are results that we have published, and which you can get if you like. Out of that, many different solutions have been developed, and I also want to point out it's not only about these research projects on a European level. There's also a national contribution at the end. So the further it goes to the product development, then we have also specific programs on the national level where we go to very high TRL levels, up to 8 actually, 7, 8, in order to turn this into products. And there are real products actually at the end of such projects, like the testing environment for an autonomous vehicle on the test stand. We say AVL driving cube. You put the whole car there, you simulate and stimulate everything. You have the radar stimulators, partly from different companies. These are also the synergies that we can create within the projects. We find partners there that can do that. We have a sensor test center also in Roding, near Munich. And on the other hand side, we have also created a new product line just for security testing. This is very important actually. With all that connection, we have also some gateways for threats, yeah, and we want to protect ourselves from that. And the in-vehicle safety testing of ADAS, this is very obvious. Actually, that was the overview, and I just want to repeat here with my last slide, the conclusion actually. It is the topics that we are working on are often very long-term. So for electric components and drivetrain development, AVL is active over more than 20 years. So this doesn't start just a few years or with the project. It starts very, very long before. The same with ADAS and the topics around that. I think we have also seen here in the different projects we have a lot of simulation, testing, engineering methodologies that go along the development process. We always have that front loading, so the earlier we can take the decision, the faster we are. And we have also the possibility to work together with different vendors, with different parties. This is also encouraged by this project, which I like very much. And I think the future goes even more into this virtual co-creation, vehicle development in the cloud, for instance. Maybe just a vision for the future. That was it from my side, and I hand over.
Horst, thank you very much for this very timely presentation. Actually, we're talking about power, we're not talking about energy in the end, right? We are interested in time. And I would like to pass the word to Isabel, so from internationally recognized and active RTO to an internationally recognized truck builder. So, Isabel?
Thank you. And why do we do collaborative research at all? Well, we do it to prepare for the next generation of product, of course, the product that will enter the market, and also because we have realized that the transformation of the transport sector will demand a broader approach, where the technologies will go hand in hand with policies development, but then also infrastructure expansion and end-user behavior. All in all, we are nowadays, all of us, much more depending on collaboration. So what I will try today is to guide you through a couple of examples and show how collaborative research will support Volvo Group when it comes to its strategy and product development. And first, a few words about us. We are offering trucks, buses, construction equipment, power solutions for marine, and also applications, and also industrial applications, sorry. We have 95,000 employees. We are producing 19 countries and selling in 119 markets. We have set super high ambition ahead. We have signed up for the science-based target for all scopes, 1, 2, 3, upstreams, downstreams, and we are aiming for a fossil-free supply chain by 2040. And we have also set stretch goals, 35% zero emission of electric vehicle globally, and then also digitalisation with a target of 50% of revenues generated by services, because we think that services are the key component to improve the logistics systems. To start with, here is our decarbonisation roadmap. And in order to fulfill the commitment to the Paris Agreement that we have, we need to deliver 100% fossil-free vehicle by 2040. We believe also that there's a necessity for a mix of several solutions, depending on application, on also operating conditions, and of the green energy supply, of course, meaning that battery electric vehicle will go hand in hand with fuel cell electric vehicle. But then we also think that we need renewable fuels, including, by the way, renewable hydrogen fuels, being used in ICE, that it will have a role to play still, in particular, you know, for the most hardest to abate application. Then when it comes to digitalisation, just a few words to tell that we are having more than 1 million vehicles that are connected, and that we are taking full responsibility from product to solutions, and that connectivity obviously will improve safety, increase also transport efficiency and productivity, and also obviously it's a key enabler for decreasing the environmental impact. So now it starts, and here's a slide to show you that in order to fulfill our strategy, we are running several research arenas in different fields. The first one is connectivity and automation. And, you know, we've been starting a long time ago. I think it was what was it, FP7 framework. It was adaptive, the adaptive project at that time, and it was about safety, and safety is, of course, still at the heart of Volvo Group. But then we are also now moving more towards cooperative system with Ensemble, as an example, or also with automated driving and confined areas with projects like FAME and MODI, which are under the Horizon Europe program. When it comes to electromobility, the second pillar, we've started exploring first hybrid technologies. I will show that in my next slides, but then we've been also quickly moving to full zero emission vehicle following the society demand and also legislation. And then finally, last but not least, you see this brings all together towards the efficient zero emission logistics, because we want to look more and more into full transport solution together with our customers. And the reason is pretty simple. It's because we realize that it's not only about trucks, you know, we are changing actually the entire transport system. And we need to make sure that the operational feature of this entire logistic system are taken into account, that they are not underestimated. And I'm thinking here obviously about adequate charging infrastructure as an example, but also about customers' acceptance. We know that, as an example, with zero-emission vehicle, they don't want to move their pattern when it comes to freight transportation. So we need to work on that together with them. If I start with the area electromobility, well, we have different European funded projects which have contributed to build knowledge in the area of electric driveline, control strategies and functional testing. And you explained very well about Obelix project. Thank you for that, with our Renault Trucks one there, which is part of Volvo Group, of course. But then also, we've been moving to batteries, where we have been looking into technologies with less critical raw material, with the Tree Belief project. So, of course, we are following research in this area as well. And then, finally, we've been looking into charging of different type of vehicle and looking into interoperability between trucks, buses, and vans. And that was with the Assured project. Maybe something that I would like to touch upon as well is the other research program and the combined effect that we can have with national research project. And I could here, as an example, give the BOM-Z project, which is a French project, and where we have been looking into system integration and energy management, and as well e-axle, where we've been looking to electric driveline. So all this together is spinning off the research. And now we are having actually electric vehicles which are hitting the market. They are sold. We are having the first place in Europe when it comes to market shares with electric vehicles. So that's now, you know, research coming to market. Yeah, maybe here just to highlight that, of course, we need the right regulatory framework to pursue our strategy and make it work. And that, I mean, of course, there's a need for cohesive policies, as always, and to bind consistent targets to secure that we are all moving in the same direction and with speed. Connectivity and automation. All in all, here we are looking very much into how to design automated functions in future vehicles, as well as how to perform testing and evaluation method. And I could take platooning with the Ensemble project, where we've been testing cooperative system with no latency, demonstrating here cooperation between all trucks OM. But then also moving on with High Drive, which is about progressing in developing technologies for connected and automated driving, as well as about extending data collection and scaling up results. And we are actually the only truck manufacturer who is working in this project in order to work and see how to communicate more with cars. Then I can also mention FAME, that we want to contribute to, because we would like to contribute to provide a long-term framework for research and innovation, and support and see also how we can go for large-scaling testing. And then finally, maybe MODI, which will integrate all of these aspects in a way where we will start having those CCAM vehicles into the logistic chain, and it will demonstrate what's needed to have this automated freight transport in entire corridors through 5 countries, I think it is. And we will handle, or there will be both, you know, public domains and confined areas which are handled in this project. But then, maybe one challenge to overcome, as we know, it's that we have a fragmented European network with different principles in different countries. And here we need harmonized regulation for testing automated driving and function. And that was mentioned earlier, I think nothing new for this audience. The last one is, if I manage exactly, so it's about this third block, the efficient zero-emission logistics, where the purpose here is really to manage to bring together the different technology blocks and to demonstrate pilots in real logistic flows. We want to demonstrate here how to decarbonize road freight transport as a whole in selected corridors, then involving, the whole ecosystem, meaning OEM, but not only, also energy providers, recharging, refueling infrastructure, and of course, transport carriers as well. I can here take as some example probably the AeroFlex project, which was an older project, and here we've been looking very much into improved efficiency with tractors and with trailer aerodynamics and combinations. And we have been trying here to demonstrate new technologies and concepts and also vehicle architecture in order to be more efficient when it comes to freight transportation. And then maybe another project, which is a recent one on the Horizon Europe program, which is Zissis, where we will show how the vehicle will do in terms of energy use, in terms of payload, and so on, and with user acceptance as well. And we're also going to compare them, together, BEV and fuel cell electric vehicle. Regarding the regulatory framework, well, of course, infrastructure is a challenge. We need here good geographical coverage for opportunity charging, but then also enough power. And then maybe to mention also when it comes to weight and dimension, we know that zero emission will require some extra weight and extra room, and more gross vehicle weight would be required. To conclude here, I'm having a movie which are, summing up all the different public partnership projects that we have been running together within Volvo. That makes me always a little bit scared because it feels like everything is ready, and that you just need to go to the market. But these are only prototypes and demonstrators, right? But maybe to conclude, yes, research collaboration is absolutely key in building knowledge. It enables us to share technology risk. It's also an opportunity, of course, to explore potential partnerships. And finally, it will support all of us in preparing standardization. Then, we know it can take some years to bring the results into the market, but then it's also important to test and learn. And we can see the results with our zero-emission vehicle, which are hitting the market today, but also with all the improvement around the connected vehicle, especially the safety functionalities, but not only, preparing also for future here. In order to move forward, we have to carry out research activities, we think, that are mixing even more the different players, and which are looking into freight transport demonstrators at larger scale. And a final word maybe to say that obviously research activity should go hand in hand with regulation development, as we need a cohesive legislative framework to drive things in the same direction. Thank you.
Very good. Very nice tracks, actually. Beautiful. Thank you very much, Isabel. And now it's time to turn to an internationally recognized research institution. I used to call TNO semi-governmental. I don't know how accurate I am, but please, Emilia, if you can take the podium.
Hello, everyone. Good afternoon. My name is Emilia, and I have the beautiful challenge of being the last speaker today, so I hope you still have some energy. I am coming from the Netherlands. I think majority of you have maybe heard of TNO as an organization, but I'll just say a few sentences about myself. I'm responsible for our integrated vehicle safety programs as cluster manager, and I hold also a position at Eindhoven University of Technology as an assistant professor. And I'm not going to, let me see if I know how to use this one. Yeah, thanks. Okay, I'm not going to tell you a lot of details about, give me a second. Yeah, okay. I'm not going to tell you a lot of details about TNO, but just one slide. For those of you who do not know our divisions, TNO is an applied research institute in the Netherlands, and we have several missions also connected to the ambitions and the impact that the other companies were mentioning in the last 2 days in the presentation. We work on integrated vehicle safety. We have mainly 2 flavors of development. You see them on the right side in this big picture. On the top, you see automated yards and connected and cooperative. Those are 2 programs we have that look at automated functions to improve road safety. And we do that for confined environments, closed environments, but also for public road. I'll show several examples that will demonstrate what we do. And in there, we develop various functionalities. We look at functional safety. How can we go from idea to piloting? And the second area we work on is safety monitoring and safety assessment. We have 2 programs, Streetproof and Streetwise. One focused on what should you ensure, how do you do scenario-based evaluations of new vehicle concepts before you introduce the vehicle on the market. That is Streetwise. And Streetproof focuses more on once you have introduced the system on the road, how do you monitor its safety. So at TNO, I was thinking for today, because this is the last presentation and then we will have a discussion with the other speakers, what would be, how can I tell history of the last 15, 20 years within 15 minutes? It's impossible. So what I picked, I've first prepared for you a timeline, and I'll give you a few examples of projects, very brief, but I want to go also through the lessons learned and the trends that we have observed, such that we can also look at the future, at the outlook. What should we do from now on? So if you look at a series of examples of projects that we've been in, it has been a bit difficult to categorize them, but you see on the top this sentence I said, we have looked at connected and cooperative automated driving technologies, and on the bottom I put safety assessment and monitoring for a responsible introduction of CCAM on the road. All the projects we have done have had in their core reducing or improving safety. So if the previous speaker mentioned we want to be 100% safe, we at TNO say we want to go towards 0 causalities, is actually the same impact that we want to create on society, improve on-road traffic safety. So if you start from 2010 until maybe, let's say, 2 days, and I put 2025, you see projects like the iGame one, the Grand Cooperative Driving Challenge 1 and 2. Maybe some people in the room still remember that competition. We had projects like Prospect looking into bicycle safety, Road Art looked at truck platooning, Ensemble was mentioned before with multi-brand truck platooning, Secretas, etc., etc. So I will not go through all the names, but we have been in a series of projects where we looked at safety assessment, cooperative driving, automated driving, and now the question is, what is the highlight that we have from all of these projects? So I will show a few lessons learned mapped onto this timeline. So here are some pictures from all the projects. Maybe some of you, because we are collaborating with many of people here in the room, are familiar to you. But first of all, more than 15 years ago, we were looking at focusing on designing automated driving functions. And if you looked at platooning at the time, everybody believed that if you do design cooperative driving cars, they will drive closer to each other. Therefore, you can increase road throughput. You would use the same infrastructure, and as you know, the Netherlands is a very dense country. So same infrastructure, more cars, you do that in a safe way, that would be great. But we looked first at safety, efficiency, let's say the stability of the whole system. So you don't want to create traffic jams, you don't want to have the system becoming unstable because it's a car with an automated function. But at that time, nobody was looking yet at all the robustness of sensors or how do you deal with some loss of communication, etc. So first we started with the core. Later, we saw that the research started evolving around How do you handle cooperative driving, automated driving, if you start sharing information but you have different cars with different brands of different masses, how do you reach consensus? Another big challenge was, how do you deal with mixed traffic? We looked into that. What happens if somebody makes a cut in front of you, a very dangerous lane change? Can you proactively react to that? Should you react very aggressively? Does it happen, does that generate down the stream a very unsafe situation if you react very aggressively? Still, safety was in the core of all the technologies that we've developed, but the use cases and the assumptions became a bit more complicated. And if you look at the last 5 years, we see that this focus is increasing even more and becoming even more complex. We see aspects like infrastructure offering much more support to the automated car. We see that there is a desire to go for more increased autonomy. So we're moving from ADAS to more level 3 functions or level 4, level 5 functions. It depends really on the application, if it's a shuttle, if it's a bus, if it's a truck or a passenger car. We also still see challenges in interactions with manual-driven cars because a lot of human aspects appear there. So the human interactions, how does the driver perceive the system, what is the perceived safety and how the behavior of the car evolves on the road, that's also very important. And we also see a big question on the sustainability of these cars. So if you would have an autonomous car, in the end, I always say, both the automated driving functions and the energy management systems, they will both try to control the acceleration of the car. So in the end, you want a car that is automated but also sustainable. So these are things that appear on the horizon. So now I want to show you just a few examples with some highlights. I've just handpicked a few applications that I can use as an example. And then I'll show you some key points we try to take for the future. So one important line throughout all these developments is that we need to ensure safe and responsible introduction of vehicles on the road. I hope everybody in the room agrees with us, because there's a lot of work to do over there. So the first example I picked is one that I like very, very much, and it has not happened since 2016, so I do hope that there are enthusiasts that would like to build this again. In 2011 and in 2016, we had 2 grand cooperative driving challenges. There was a project, European project called iGame, and in 2011 you see a picture on the right on the top. There were several teams, and in 2016 there were 10 student teams from Sweden, Spain, France, Germany, Latvia and the Netherlands coming with their car, with the students, in a big lab, trying all of them to communicate with each other, and a lot of fun things happened. And also a lot of nice results came out of that. How do you communicate? How do you align with each other? How do you transfer an acceleration signal from one car to another? So one of the highlights of these initiatives was that you innovate through collaboration with students, so really practical at the cars, but also that you would have a first step to standardize in Europe the communication and the interaction between cars. So what we saw in 2011 was mostly passenger cars, but in the 2016 edition there were also trucks. The purple one was from Chalmers, so various teams. I think this is a very, very good example of how collaboration is happening in Europe, and you don't see it in other continents. So I picked this one as a first example. I hope we will have such a competition again. The second example I picked for, or the application I took is platooning, because we have learned a lot from vehicle platooning. We had some internal national projects starting 2010, 2008, 2010, and the first European project we worked on was RoadArt, together with MIN and the university in Greece, and with some companies in Germany, IMST. And there what we tried was, assume you have platooning. What you see in this picture is 2 screenshots of a movie that you can find on YouTube with the GPS position of trucks in a tunnel. So the assumption was, we have platooning, we put it on the cars, but what happens if you enter a tunnel? Your GPS will have a lag, you will not know exactly how accurate your localization is. What do you do? So there we implemented predictive capabilities between trucks. You predict what's happening, you share these predictions. In case your localization is wrong, or in case your GPS is not functioning, you rely on these predictions. Question was how long, how good it can be. The results were quite good. Then I took the highlight of these projects in this domain, that's Ensemble. It was also mentioned by Volvo. But I cannot tell you everything that happened in this project, so what I want to just invite you is have a look at the website, but I want to mention the big takeaways. So we have introduced the difference between platooning as a support function or versus as an autonomous function, which makes a great big deal of difference. We at TNO have done a reference implementation, and also we used hardware in the loop to verify and validate this. There are, of course, if you use multi-brand trucks, you have implementations of each OEM. They have their own vehicle controls. And we have also looked at proactive tactical planning and decisions, even starting in the road art project. And we have actually taken from just ideas, how would this look like in theory, and we went to multi-brand platooning, and that was quite good. So there you see that there is a combination of autonomous functions, but also cooperative between cars, what could happen. So that was the first application. I have two more. Safety of pedestrians and cyclists. One of the first projects I had in the timeline was Prospect. The key topics that were developed in that were all kinds of methods for the safety of pedestrians and cyclists. You see here the big 6 clusters of that project. So from looking at what are the accidents that injure cyclists and pedestrians, how does the statistics look like, when does that happen, can we derive the next use cases that should be tested, how do you create a mitigation strategy once you have these use cases, and how can that be tested? There was also a new bicycle model developed in that with a lot of flexibility. The outcome of projects like this was that we have now new standards and testing procedures for Euro NCAP on cyclist interactions. So that's quite impactful. These research kind of projects, they provide insights to create these new standards. Then I want to show another example of more recent projects, that's Secretas. And because yesterday at the beginning of the session somebody was mentioning synergies, this is a KDT funded project which focused on how are you going to rely, what will you do if you have situations where the communication to the car is hijacked. And the use case we worked on was an intersection in Helmond in the Netherlands, where you assume you arrive at an intersection and you receive information about the pedestrian that enters the intersection, but what you receive, it's wrong. What do you do? So we worked on methods to detect anomalies in the communication, to do something about it, and also to realize, okay, this is a specific type of anomaly or a specific type of fault. And the last one that I think it's very much worth mentioning is a project that will finish next month. It's a bit even more recent, that's SafeUp. It's a project that I've been in from the beginning. I've been in majority of these projects except Prospect. And here we looked at extending the ODD. So as I said in the timeline, when you work on the core functionalities, you do not work on all the small things that can happen on the road. But as you know, as we all know, on the road there is bad weather, there is special conditions, there is night, there is day, so there's quite a lot of variety. In SafeUp we looked at what happens, and maybe you all remember the Uber, no, not Uber, was the one of the robotaxi companies in the United States that had an accident with a cyclist in very bad light. So in SafeUp we look at bad weather, what do you do with the car, can you even predict what a pedestrian is doing if you see him so late, and how do you evade that? So the last application I wanted to say is related to safety assessment, and then I'll show you the highlights. I think we're still, yes, 1 minute? Yes, 1 minute, 2 slides, I think it's good. So looking at all the safeties, because I mentioned we need to have a way to introduce these cars in a responsible manner on the road. There are some regulations which came, like the GSR, but there has been quite some projects which have looked at various things that need to be tested. And I wanted to mention Head Start, because Head Start has looked at how do you test and validate cooperative and automated cars, but also including aspects like vehicle to infrastructure, cybersecurity, and positioning. So that project developed and demonstrated methods and procedures to look into these aspects, so that's very good. You see there a picture of how it was split between virtual testing, proving ground testing, and field trial testing, and this is a discussion also right now ongoing. But at least in this project, we have seen a way how to look at vehicle-to-infrastructure communication. So that leads me to my last slides. One, I want to show you how we do it at TNO. Just one picture. We go from all the facilities we have in our Mobility Applied Research Quarter, and we use all the connectivity we have. We even have an equipped highway on the road, and we scale up to societal level. So what we want to do is to be a partner for public and private companies to go from a demonstration on a street life box, like gathering data on the road or using something in a car or in a driving simulator setup, and scale that up. What is the impact on society that we are creating? I'm an engineer in this corner making a very small function. What does my function really mean for the large-scale solution? We do that in the typical cycle. We have added one line on the top, safety monitoring. So we go from specifications to implementation and to assessment. And if I now look at the future, what are the key lessons learned and the outlook? My first takeaway from all these projects is that these EU-funded projects sometimes bring parties together that would not easily come together otherwise. So I have debated with my colleagues what's the main takeaway from all these projects for us. I think one of the biggest powers of this project, of these EU-funded projects, is that you see connections that you would have not seen otherwise. And then 3 other small points. We see an increased need of digital infrastructure supporting automated and cooperative driving. And that will only happen if there is some sort of measure of quality and trust. We see that that's not really there. We also see that safety monitoring and safety assessment is very important to bring cars on the road. I mentioned that, and as a last point I want to mention, I think on all the automated driving functions we need to develop cars that are context aware, scalable, robust, and they can adapt on the road. So the same car driving the same road might need to react differently to different conditions. And that means adaptivity, scalability, and I strongly believe we are not there yet. Otherwise, we would have all kinds of autonomous cars running on the road in high level of automation. Those are the highlights of our projects. Thank you very much for the time.
Thank you, Emilia, Isabel, and Horst, for these very clear, very inspiring presentations. I think we have to pass now to the second part of this session that involves a discussion. I would like to start with a few questions to you and maybe break the ice and then turn to the audience for their own questions. So my first question would go to Isabel. We have been discussing, actually it was a lengthy discussion, about the EU-funded activities and how they contributed to the development of processes and your products. But you are an international company, right? You said you are operating in more than 110 countries, and you produce in something like 19 countries. So how are these integrated activities here, or how these activities that take place here in Europe interact and integrate with similar research activities from other parts of the world, both ways? Is there such an interaction? How do we gain? How do we, as Europeans, I mean, how do we export our research activities?
Yeah, absolutely. Does it work?
It does if you get closer to it, yes.
Yeah. So, it's completely integrated, you know. It's about building blocks that we are working on and which are evolving with time. I think I showed that, especially on the electromobile side, maybe today, that we are having, first of all, a European project that will feed in French national project. And by the way, what I didn't mention is that this French national project, BOMZ and e-Axle, they will feed in afterwards European funded project again with Zissis. So this is like, you know, knowledge spinning off, taking things every time at the next step. And then to answer your question about being global, absolutely, we do export our knowledge out, as an example, in the US, and we will actually go there as well for public partnerships, working together with authorities. I'm thinking here in particular about the Californian scheme. where we are having the LIGHT project, where we are kind of exporting our electromobility platform to the US. So yes, this is having a huge impact what we do in terms of research collaboration here in Europe that will support us to go out and reach out other markets.
And what about the other way? I mean, is there an impact from, for example, funded research in the United States coming back to Europe somehow?
Most likely, but I'm a little bit unsure here, I have to say. I prefer not to say anything wrong, but most likely, because yes, it's again, it's a matter of spinning off, it's a matter of building knowledge. Then obviously when we go out to the US or to some other market, we need to go for specific market adaptation as well. But then we have global team, we have synergies. Group Trucks Technology is a global organization, and the engineering team are working closely together. So, I mean, yes, the knowledge is, we are not working in silo, but we are working on global platforms all together. So synergies, I understood, was the key word, and of course for our industry it is as well.
Thank you very much, Isabel. That's very clear and very, very convincing, I would say. May I turn now to Emilia? I'm not, you touched upon it, but I would like to kindly ask you to elaborate a bit more, with focus on safety in particular. Can you say a few more words on the role of the research on standardization? How your activities, TNO's activities, I think it was obvious from your presentation. Still, I would like to kindly ask you to make it stronger. How do your activities contribute to standard development, standardization developments in Europe? And possibly, although standardization is not the same thing, how do they contribute to regulation, to regulatory activities? Can you give us a few more examples or make it a bit clearer?
Yes, of course. So we have some clear examples of how research can contribute to standards and also help legislation. If they would be totally decoupled, then probably the standards and the laws would be unfit for the industry or unfit for their purpose. So there must be a clear link between what you learn from practice and from research into standards and also legislation. So we had, for instance, projects that contributed to car to bicycle interaction standards. That was one example you saw in my slides. Another one is working towards vehicle-to-vehicle communication or other types of communication from vehicle to infrastructure. We have done a lot of work there. But I think still there is a lot of work to be done. So I mentioned in the last slide quality and trust. I think there are some big needs, not only on having multi-layer, secure and resilient and trustworthy information sending from one party to another, but also you would like that there is a way to verify if the information that you send from A to B is not only secure, but also it's something that you can use. So that's one example, and I think we have to, the second example I could mention is for the future, there is all this discussion on introducing automated driving in Europe in various countries. And as you know, a driver in the Netherlands is not the same as a driver in Greece or in Italy.
Definitely not.
No. So we have this discussion now about roadmanship and having a reference human driver model to compare the automated driving with. There's going to be a lot of interaction between standards, probably also legislation, some iterations, and what the research will discover. How do you even quantify safe and social driving? There were a lot of discussions about users and user groups. Maybe what feels okay for me does not feel okay for you. If you have an autonomous car that will behave okay with respect to the Netherlands, will it also behave okay in Germany? Or do we have to change behavior? Do you have to let the driver know or the passenger know that you have changed behavior? So all kinds of questions there. So although there are some regulations in place, probably they will need to be further tuned. And I'm not yet mentioning the AI usage in mobility or other aspects. So there's quite a lot of interesting things.
Why not mention it? I mean, because, this is intriguing, and it's not only for this particular area, but it is very important for this area. What do you mean that there will be adaptive software that will control the functions, the safety functions of the car if it is driven in the Netherlands or in Italy or in Greece, as you said?
That's the question.
Yes, it is a question also for
Because you asked me what should research help towards standardization. This is what research should help. But there is already adaptive software in the cars to some extent.
But not for safety.
No, not for safety critical functions. But you do see in United States sometimes articles like, did Tesla just slow down my vehicle? And that means that there has been an update on a safety critical function, actually on the behavior of the braking of the car. So we have to discover. We need a new project.
Thank you. May I now turn to Horst with a question. I was looking at your table. You covered 13 years. I mean, if you wanted, you could bow another 10 years back or so. However, there is always this question, in particular coming from, as I said in the beginning, from the specifications of the project. Impact. Show us impact. Do you have now, after so many years, do you have an estimate how long it takes, what effort is really needed to come from a new idea to an exploitable product, even if it is not sold or not sellable, to an exploitable product?
The question is actually not easy to answer because it depends. Let's start with that. But overall, what I said is we need to anticipate the future. I gave the example that we started off with the ideas, the first developments about electrification more than 20 years ago. So you have to look in the future and you have to have some ideas where will this develop, yeah? Especially for the electrification at the beginning, it was very hard because at that time, 20 years ago, everybody said, okay, electrification, forget, yeah? So, and even 10 years ago, everybody said, good, electrification like Tesla, simple e-motor developed Siemens 100 years ago and inverter. So we know very much more in the meantime. And I think you always have these cycles that you have a specific idea and you have to go from, we never started at lowest tier L level as a company, let's say, as industry. This is something what the research organization, the universities have to do, the first step. So we start with a principle. We do not invent any principles, actually. We do not invent quantum sensing. We do not invent whatever, wide band gap semiconductors for us. We take them just and say, okay, we can apply that for a specific solution, and then it takes a certain time. So typically one project is not enough. Yeah, so there will be what I showed there, and this was in Asterix, Obelix, this was this sequence actually, where at the end we had this silicon carbide usage within the tester and also battery tester actually. We used the same technology there, but also in the vehicle. This was a time span, you see it there. I cannot, numbers is always difficult, but whatever, it takes 7 to 10 years actually sometimes to get from this first idea to really a product that is stable and completely there. On the other hand side, we have also discussed it before in the battery development, where they started off with the development of new battery packs. And at the end of the development phase, they say already, okay, somebody else had newer ideas. We for instance, this was this discussion, the cell to chassis development, yeah, which was not considered at the beginning. At the end of the project, it's already maybe standard. Some people said it would be. So the developments are sometimes going very fast, and we have to tackle that also. So there are different speeds we have to cover, but it takes some time, and you have to anticipate a lot.
Thank you, Horst. Thank you. Now I turn to the audience. Maybe there are some questions in this direction to our speakers. So I see Andreas Dorda in the middle here. It would be nice if you could state your name and affiliation.
Yeah.
Thank you, Andreas.
Yeah.
Although I knew you.
Yeah, okay. Andreas Dorda from the Austrian Ministry for Climate Protection, Environment, Energy, Mobility, Innovation, Technology. Being responsible for national transport R&D programs, I'm interested in your opinion and your strategy choosing between European and national funding programs. Because I'm witnessing, speaking with our industry and research institutions, two different and exactly opposite approaches. Some of them are starting on the national level, just basic research, and they're even grateful that we give them the opportunity to embark in a new direction and getting more experience to get competitive on the European level. But when they are approaching higher TRL, they are interested to integrate in European projects simply because they are their clients, especially in a supply country like Austria. And then we have the opposite. Companies just saying they want to start with lower TRL on the European level, and when it gets more confidential, they are turning to Austrian cooperative funding programs, and if it's getting very confidential, they are preferring funding schemes where they can apply as one single company. So you have two different approaches, and I would be interested to know which seems more appropriate to you, and if both are valid, just explain in which area one of the both are most suited. Thank you.
Thank you, Andreas. Who would like to pick this up?
I can start because I'm not sure that there's a strategy. I think the way it works is, first of all, we need to understand what are the research area. And what we do is we go to our experts and we ask them, where do you feel that we need? And of course, in line with the company strategy. But first of all, it's about supporting here in understanding what are the right research fields. And this, I would say, we do both at national level and then also, of course, at European level. And then, it's about opportunities. So it's about finding the right partners and finding the right collaboration to pursue your goal. So it's not, that there's a scheme from the very beginning. Then I can agree with you that, indeed, when we are getting closer to the market, when we are going closer to standardization, then of course, and I think I said that during my presentation, probably the European funding is a way to reach out to more countries, to more stakeholders, and to prepare for the standardizations. But again, it's all about, research is about gaining knowledge. So, and we don't do research only for funding. We do it for sharing technological risk. We do it also for being competitive, for boosting innovation, for boosting our leadership, and sharing knowledge and understand who we can cooperate with and collaborate and learn from.
Horst?
May I add? Also, we discussed it a lot in this direction, but I think on national level you have often not so many partners involved actually, where you start off, but also on lower TRL level where you develop specific technologies that are there, if they are there. Yeah, that's always the question. For especially for Austria, we don't have an OEM really. Yeah,
I think you have BMW, don't you?
Yeah, BMW on specific topics, yes. Yeah, but on other topics, not. So we have to go on European level actually to get that information that we otherwise would not get. Yeah, this was also mentioned. I think I don't know who mentioned that, the possibility to do collaboration. Yes, Emilia, you mentioned that we can do collaboration with partners. Either we know already upfront, we want to collaborate with this partner, or even sometimes there is the possibility to work with partners we even did not think about before. So that means we need both schemes, and it's all right what you also said and what Isabel said. At the end, so the finishing, actually, there's probably, you have all the knowledge, you do not need so many collaborations anymore, but somewhere in the middle and at the beginning of the TRL levels, you need that very much, either on local level where you have it, smaller scale, but on European level on a larger scale.
Emilia?
Yes, I agree with I subscribe. For us, it's a bit of a mix between the two strategies that you mentioned, but it's not so much IP driven. So when you talk about safety of the roads and automated driving, there are topics like, for example, scenario-based assessment to introduce new automated vehicles. That's one area where we work and we have put a lot of effort. We believe that if you don't harmonize around different countries in Europe, a Dutch solution would not be a proper solution, or you need somehow to scale up and we need to help each other across country. Otherwise, the solutions are not going to be scalable and they will not be well adopted. So sometimes we have to go outside of the national borders to just be sure that solutions are adopted across EU. That's one scenario. And the second scenario, when we choose to stay more national, is when national parties approach us, because we are a knowledge partner, they approach us and they say, well, I am the port of Rotterdam and I want to increase the digital part of my port by allowing maybe some automated cars drive around. And then we look at the specific challenges from those partners and try to figure out what's the challenge. But oftentimes you need to find these EU partners in a more broader ecosystem. So for us, it's always very beneficial to hear about what's happening in other countries.
Do you think you have your answer to a certain extent? Because to me, it is both ways. There is no rule, and it is very much intuitive at the same time. I mean, it depends on the topic, it depends on the people who are involved, which way. But generally, you start with something that needs collaboration and therefore public funding, and then as you progress, then the whole thing goes thinner. Any other question from the floor, or we are standing between? I don't see that. Yes, thank you. I'm sorry, the lights, yes, very good now. I can see that. So there was a lady at the back, I think.
Thank you. I'm Eveline Marlier. I work for the Research Institute IMEC that is based here in Belgium. Thanks for sharing your success stories. But I have a question. During the day I heard a lot of success stories, but I think most of us worked on EU projects or other projects and had cooperations, and I'm quite sure that we must admit that some projects are not equally successful. And I think it's nice to learn from each other's failures, because we're all working in innovation, and innovation is a process of trial and error. So it would be nice to hear from you a story that was less, or a project that was less successful, and what was the reason behind it? Because I think that we can learn as much from each other's mistakes as from each other's success stories.
Thank you. That's a very good question, actually. And it was my last sentence, but then I said, okay, I will leave it for the end. But thank you very much. So who wants to pick this up? You don't need to mention the project, by the way, but you just give the example, if you have something.
Yeah, I can start. The problem is everyone will know what I'm talking about because, I mean, from my perspective, but you know, it's very personal. I think I was so disappointed that platooning is not sold out. You know, that it's not out in the market. But then, if
already, you mean?
Already. This is the already. you know, for me it was a failure because I was really believing in it, and I thought, wow, now we are there. And if you remember, you know, automation 2017 was it? It was like in 2 years it's there. And we learned it's not the case. We learned it's much more complex than that. It's about technologies, but not only, of course, it's customer acceptance. I mean, everything that has been discussed today. So what I'm trying to say here is maybe what could appear like a failure because the project did not went out to the markets, that it's not yet sold, it's not yet, not already. And it's about learning from these failures and moving on to the next step. And yeah, that I don't know, maybe that will be out in some years and we learn from that and we move on.
Thanks.
Horst? Maybe I can add, I think it's, I do not think about the specific project that failed, but I think it's very important for a success factor that you you develop a common picture. Actually, you start early enough to define your project, and you should know each other. So sometimes, if you maybe have project where you do not need each other very well, it takes a lot of time to get this common understanding. So this might look like a failure at the end, where you need a lot of time to get this common alignment. And to develop this trust and cooperating. So often a successor project of one project is often more successful than the previous one if you have the same consortium, a similar consortium. Maybe just one example.
Emilia?
Yeah, maybe what I could add is that it depends a little bit how you quantify success. What do you consider successful? I cannot handpick a project, but I have examples where I can say I would have loved things to go differently. And one that comes to mind is projects where you have a lot of partners, a lot of partners, quite the very large ones. One aspect of defining success would also be that there is enough knowledge sharing and that everybody learns from each other a lot, and data from pilot 1 is also available for pilot 2. But sometimes during the project you realize that, I don't know, in pilot 1 some data was logged and in pilot 2 not the same data was logged or not with the same frequency rate, or that it's very hard. It requires quite a lot of time to align between all of these parties and learn from each other. So if knowledge dissemination and learning from each other is a factor of success, that becomes more difficult with very large projects. But you could also say, yes, but in these projects there are smaller groups of parties that work together and that has gone very well. So I don't know. It depends from project to project. What we try to do is to put it in a more positive manner and say, what did we learn from this project? What are the lessons learned? And let's try in another project again. So try to take the lessons learned from each project.
Do you think you have got your answer, or?
I think indeed it also depends on how you define success stories. It also can, is related to how you define fail, because fail you can also you can see it as abbreviation of first attempt in learnings. So
Exactly.
So if you have, for instance, a project that says, let's have automated cars that reduce all the road causalities of the future by 10%, you don't know the road causalities of the future, but you try. If you have reached 9%, I think that's great, but it's still a question, is 1%. But the first example I gave, the Grand Cooperative Driving Challenge, there has been some collaborative research papers that have resulted out of those projects that are extremely impactful worldwide. So one measure of success is also how many people are using the research that you have done. Although it didn't reach practice and there is not yet on the market a solution for platooning, there's still quite a lot of knowledge impact that was generated. So that's also a measure of success.
May I just add, because from IMEC, yeah, we started a project together, Hyperform. It was in KDT, nevertheless, but there was the semiconductors together with the system development, the application within the vehicle. At the beginning, for instance, the semiconductor industry, if they said device, they had in their head actually the super mini, the die together with the housing. This was the device. If you ask somebody from the supplier industry, like AVL, a device is a measurement instrument. A system is a measurement instrument, for instance, or a device. And for the car manufacturer, they have other pictures in their mind. So they're looking at. So everybody at the end is looking on different levels, for instance. So you have to develop also your common understanding if you have a huge variety of different partners. This is what you mentioned. If you have very big projects, there is a challenge and a high likelihood to fail if you don't do that.
I think failure is synonymous to learning, actually. So if you don't fail, you never learn in the end, right? And this is how we progress. And I believe what you stressed is that there are many problems in these collaborative large projects, and they have to be taken into account. They are not necessary. They don't produce at the right time the result, as the wished result, I would say, as Isabel pointed out. But maybe down the road it is there, and we all know it is somewhere down the road. I think I can ask all three of you a final question, which I would kindly ask you really to answer very honestly in the end. So this question is, yes, we have been talking about success. Yes, we have been talking about your very important experiences from collaboration and from collaborative projects. So can you share with us what do you think should change in the future? Do you have any suggestions for what could be the improvements in the current collaborative research and innovation scheme that we have in Europe that you would propose based on your broad experience as you showed? But honestly, what do you think you could do? You could suggest to the, I think, regulators in the end, Emilia, on this? Or everything is perfect, it's fine. We even transform failures into success in the end. But do you have any suggestions for improvements?
Well, I have to rely on also the stories I hear from my colleagues, because I have been in a limited amount of projects from start to finish. But I think we have heard a lot about synergies yesterday, and we've heard a lot today about users, and also about the needed interaction between parties that have not met each other, or various collaborations. If these are so important, I think we need to keep an eye on the fact that these things are actually happening. So through projects, I've seen in the magazines that are on the tables outside, there is quite a lot of synergies, there is quite a lot of cross-project collaborations or awareness because of the parties which are involved in different projects. So the same parties in multiple projects, therefore you have awareness of what the projects do. But if synergies and users and collaboration is important, then we also have to evaluate it regularly to see, is it really happening? Do we do enough dissemination of knowledge? But from my experience, I think collaborations are going quite good.
So you mean more evaluation during the project? Is this what you meant?
No, just encouragement to go from collaborate from project to project. I think there is enough. So I think if we continue the programs we have, the roadmaps that we have are very, very interesting and very good, touching upon critical aspects with good research directions. Mm-hmm. So I don't have very radical suggestions.
Okay, thank you. Isabel.
Yeah, I always tend to take it from the end user perspective. So I would say that we should try to go even more on a systemic way taking into account the end user to start with, then maybe energy plus supply, infrastructure, providers, and to go for demonstration at even larger scale, more and more. And then, yeah, of course, connectivity. I've been talking about the decarbonization side, but integrating also all the digital aspect into the vehicle and for the end user at the end. Then, second point, we are competing with other regions who are super efficient as Europe is to provide some support for research and innovation. And I think what we need is speed and flexibility. And we've been talking about how long it takes to get things out in the market. And sorry, I'm always into getting the product into the market, I know, but I mean, when I started this, working in the automotive industry like 20 years ago now, I mean, it was normal to say we need 15 years of a research plan, we need 9 years for a product plan, but this has speed up so much, we cannot say that anymore. And so I think, yeah, we need accessible framework, agile, and speed even more. And I heard that there's this new Green Deal industrial plan that has been announced. So yeah, it's good. I hope for the best there.
Thank you. So, larger demonstration projects and speed. Okay, very clear. Thank you. Horst.
Okay, maybe if you ask me that question, two things comes into my mind. One is we are talking about research and innovation. So research is the first step. The last step is innovation. Innovation means we make money out of that, what we do, because this is what we need at the end to make everything turning around. Yeah. And I think this is something what we have to look at. I actually ask also today sometimes what are the business models behind that. We have also to think about that. That's very important. How do we make money out of that? How do we bring everything forward in Europe? And how do we do it together with being environmentally friendly, sustainable, green, etc. So we have to bring that together, but we have to earn money out of that. And maybe this also should be taken into consideration when we decide where do we go from the research topics. But this is up to us associations also to bring that in. Yeah, so that's also on our side, but together with the Commission. Maybe that's one important point to look at. And maybe one second point I would just like to mention. What I see sometimes now is that some projects are very small in kind of budgetary, let's say, framework. And if you have a very small project with 3-4 million, for instance, this is even there at the moment, then you do not have very much space of this collaboration. Yeah, they need not be super huge because then you have the problem, yes, as you mentioned before. But if you go very at the low level, then there's no much room for collaboration, and you do not have that possibility that we were talking, which is beneficial if you have a certain amount of environment and collaborations that you can do. So actually, I would suggest not to make such very small projects, rather not 3.5 million, maybe always higher than 5-6 million, maybe 6 to 10, and then there are higher projects of course also. So maybe that's some wish into the direction of the funding authorities, Commission.
So business models and larger projects for innovation in particular, not for research.
Not too small projects, let's say that in that way.
Good. So I would like to kindly ask you, it's 6 o'clock, I think we're quite on time, and I would like to kindly ask you to join me in an applause to our speakers. for the effort they did